Alrighty, so this is class notes for section 11.5. We're going to be talking about inscribed angles and polygons. So first, the word inscribed sounds very similar to inside. And in fact, we are going to be talking about things inside a circle. So first we have an inscribed angle. And an inscribed angle, the vertex and endpoints lie on the circle. Alright, so when I draw my inscribed angle, I'm going to draw my vertex, a point on the circle, and then draw my two sides so that their endpoints lie on the circle. So there's my vertex, my two endpoints, and notice that the two sides of my angle, my inscribed angle, are chords of the circle. Alright, we also have an intercepted arc, which is the arc between the endpoints of an inscribed angle. So on our picture here, if we're talking about this inscribed angle, this is the intercepted arc between the endpoints of that angle. Alright, so next set of definitions here, we also are going to talk about an inscribed polygon. That is an polygon whose vertices all lie on the circle. So we can draw any polygon, a triangle, a quadrilateral, a pentagon, but all of the vertices have to lie on the circle. And then the sides, you notice, are also all chords of the circle. So here I have an inscribed pentagon. So when I have an inscribed polygon, we say that the circle is circumscribed about the polygon. So in my example, the pentagon here is inscribed in the circle, and we can say the circle is circumscribed about the pentagon. Alrighty, now that we have our definitions, we have three rules we're going to learn today. The first rule has to do with an inscribed angle. So the rule says if an angle is inscribed in a circle, then its measure is half the measure of the intercepted arc. So if we're looking at this inscribed angle here, that is angle ADB, we know that that has to be equal to half the measure of the intercepted arc. So let's call the intercepted arc is the arc from AB. So it's half the measure of the arc AB. It works the other way too. If we know the measure of the arc AB, to find the measure of the inscribed angle, we double, to find the measure of the arc AB, we double the measure of the inscribed angle, ADB. Okay? So, if the inscribed angle here is x, then the intercepted arc has a length of 2 times x. The inscribed angle is half the intercepted arc. We're going to do an example of this. Number 1, find the measure of the inscribed angle or intercepted arc. It'll give us one, we have to find the other. So in example A, if the arc NP is 100, we know the inscribed angle is half the measure of the arc. So the angle NMP is equal to 1/2 times 100, so it equals 50 degrees. In part B, if we know that the measure of this inscribed angle here is 105, if we're trying to find the intercepted arc, we have to say that the intercepted arc, so that is the arc Z going through W and ending at X, is equal to 2 times that angle, 105. So the measure of the arc is 210 degrees. So to find the inscribed angle, you half the arc. To find the arc, you double the angle. Alrighty, next rule. Now we're going to talk about inscribed triangles. So, if we have an inscribed triangle and it is a right triangle, then that tells us that the hypotenuse is the diameter of the circle. So if we know that a triangle inscribed in a circle is a right triangle, it means that this has to be a diameter, meaning it goes through the center of the circle, and it works the other way as well. If a side of an inscribed triangle is the diameter of the circle, then it means that that triangle has to be a right triangle. So if you have a circle and you draw a triangle inside of it going through the center of the circle, making that a diameter, no matter how you draw the rest of that triangle, it has to be a right triangle. And the angle opposite the diameter is a right angle. So, looking at example 2, it wants us to find the value of x and y. Looking at our picture, we can see that this inscribed triangle here, this side, AB, is going through the center D, so it's a diameter. Since that is a diameter, then that means that the triangle must be a right triangle and the opposite angle must be a right angle. So therefore, x must be 90 degrees. To find the value of y, we know that all the angles in a triangle add up to 180. So I can take y plus 90 plus 50 equals 180. If I subtract the 90 and 50 over, I get that y must be 40 degrees. Alright, third and last rule for today. If we have an inscribed quadrilateral, so a four-sided shape inscribed in a circle, then it must be true that the opposite angles are supplementary. Remember, supplementary means they add up to 180. So, in our picture here, we have a quadrilateral, a four-sided shape inscribed in the circle. So we need to look at the opposite angles. Here, angle D and angle F are opposite, so we know that angle D plus angle F must equal 180 since they're supplementary. But we also have E and G opposite from one another. So therefore, angle E and angle G must also add up to 180. Alright, so look at example 3. We have a quadrilateral, it's inscribed in the circle, so the property tells us opposite angles are supplementary. So to find y, look at its opposite angle here is 120, so we can say y plus 120 adds up to 180. Therefore, y must be 60 degrees. To find z, we look at the opposite angle across the quad is 80 degrees. Therefore, z plus 80 must equal 180, and z must be 100 degrees. So all we're saying in the third rule is that in an inscribed quad, that opposite angles are supplementary. They add up to 180. Alrighty, there are 3 checkpoints on the next page. Pause, try them on your own, then unpause and check how you did. Alrighty, so check and see how you did on each of the 3 checkpoints. Right, if you need more time, pause. Otherwise, I'm moving on to the last example. Okay, so we're given a figure here, and it wants us to find several missing arc and angle measures. So let's look at number 1. We want to find the measure of arc BE, so that arc here. Well, we know that the inscribed angle that's related to this intercepted arc is 47 degrees. So to get the measure of the arc, we have to double that. So 47 times 2 gives us an arc measure of 94 degrees. So I'm going to put that out here outside of this arc. I know that that has to be 94. Okay, so now, next thing I'm trying to find is the measure of angle AED. So I'm trying to find this angle right here, AED. How am I going to find this angle? Well, we know that this angle in here is 80 degrees. in this angle in here, can we find the angle BDE? Oh, I skipped number 2. Let's do 2 first. BED, this angle is related to this intercepted arc. We know it has to be half the measure of the arc. So 94 divided by 2 will give us this angle is also 47 degrees. So if we want to find the measure of angle AED, we want to see that this is a triangle and all the angles have to add up to 180. So we can say that if I call it angle X plus 80 plus 47, it tells me that this angle must be 33 degrees. So this angle in here is 33 degrees. All right, we have 1, 2, and 3 done. So let's look at 4. 4, we are trying to find the measure of the arc AD, this arc here. So to find the inscribed angle that is related, you want to go from each endpoint of the arc, see where those meet, and it in fact is at the angle AED. So if we know the inscribed angle, we double it to get the arc. So 33 times 2 gives us an arc measure of 66 degrees. All right, so we are on number 5. Now we want to find the measure of ABD. So ABD is this angle here. Now I already know the measure of the arc, and our rule tells us that the inscribed angle is half the measure of the intercepted arc. So I want to take 1/2 of 66, or 66 divided by 2, which gives me an angle measure of 33 degrees. So this angle in here is 33 degrees. All right, number 6. Our last one here, we're finding the measure of arc DE, which is this arc right here. Now, we don't have an inscribed angle. Look at this angle here going from the endpoints of E and D. They meet up, but they don't meet up on the circle. So since the vertex isn't on the circle, that is not an inscribed angle. So how are we going to find the measure of this arc? Well, we can notice that we have the arc from D to A, from A to B, and from B to E. So since we have all the other arcs in a circle, we know that all of them must add up to 360. So we can say the measure of DE plus 66 plus 94 plus 100 has to equal 360. So if we add these up, the measure of DE plus 260 equals 360. Therefore, the measure of the arc DE must be 100 degrees. All right, so we found 1 through 6. A lot of stuff to find. Last question, it asked, are triangles ABC and triangle DEC similar? So let's find these on our circle. So triangle ABC is this triangle here, and triangle DEC is this triangle here. So to see if they are similar, we want to look at the angle measures. In ABC, we have measures of 47, 33, and this angle in here must also be 80 degrees because these are vertical angles. And on DEC, we have 47, 33, and 80. So since the angles are the same, then yes, they are similar. And they're similar by angle, angle, angle. Alrighty, that is all for today.